With the introduction of wearable technology, we hear a lot of coaches and a lot of athletes saying, we're not training harder, we're training smarter. What I'd like to do in this next video is talk through some really practical evidence suggesting that training harder might actually be training smarter. So if we look at this next slide, you can see a graph that represents the acute to chronic workload ratio versus injury risk. A lot of you would have seen this graph before. Now I'd like to talk through some of these points. What we can see here is that when we rapidly increase load, the load that we've done in a recent amount of time relative to what we've been prepared for, the risk of injury goes up. When we increase load quickly, the risk of injury goes up. Now, with this graph, the variance in injury, around about 53% of the relationship here is explained by the acute chronic workload ratio. So it indicates that the acute chronic workload ratio, or load in this example, is a big rock. It explains a large chunk of why injuries occur. But it's still only 53%, which means that 47% is explained by other variables, other factors. So while load's important, it's not the only variable that's important in injury risk. The second thing to keep in mind here is that while we can see on average risk go up, risk does not equal rate. Just because we've increased the risk of injury doesn't necessarily mean that all of our athletes will break. And the final point here is that there's typically a delayed effect. When we spike workloads in this week, we typically don't see an increased risk of injury in this week, but we see the risk of injury occur somewhere down the track. Typically we see it in the following week, but some authors have seen it in the 3 weeks following a spike in workload. You can also see here that while it's very clear when we increase the acute chronic workload rapidly, we get an increased risk. But you can also see the curve start to swing back the other way when we go through big reductions in workload. So what it tends to suggest is that big troughs in workload might also increase the risk. Now, I don't know for certain whether the trough in workload is responsible for the increased risk, or if a trough simply precedes a spike. What it does suggest though is that from an injury perspective, our bodies handle this kind of loading pattern, small increases, small decreases in load, much better than it handles big spikes and big troughs. So I've spent a fair bit of time talking about the acute chronic workload ratio. If we go to the next slide and we have a look at the original study that looked at the acute chronic workload ratio and injury risk. This was done on one sport, and you can see that same J-shaped curve, that when we rapidly increase load, the risk of injury goes up. So it would be really easy to think that injury risk is all about the acute chronic workload ratio. But of course, we also need to consider the denominator in this equation, and the denominator is chronic load. Now we can draw a danger zone and a sweet spot when we plot chronic load versus injury risk. And this is the true paradox. When our workloads are low, when our chronic workloads are low, if we wrap our players in cotton wool, you can actually see that injury risk is highest. But if we can safely build to higher chronic workloads, you can also see that injury risk is close to zero. So higher chronic workloads act to protect our players against injury, protect our athletes against injury. So how do we get to those high chronic workloads? You have to train, and you have to train pretty hard. All of us want to get to those high chronic workloads, but we can't just go from 0 to 100%. We need to progress our training loads in a systematic way. We want to build to chronic workloads. We can use the acute chronic workload ratio to systematically build to those higher chronic workloads that give our athletes the best chance of reaching peak performance and also minimizing their risk of injury.